you ever imagined being able to travel from one place to another in such a short amount of time that it feels almost like magic? Haven't we all? The concept is evident in pop culture, books, movies, video games, and those fast travel mechanisms in space take many forms in science fiction: warp drives, hyperdrives, and a whole array of amusingly named contraptions. Today, we're going to focus on wormholes. Hey there, observers! Beam here. In 1935, physicists Albert Einstein and Nathan Rosen examined the shape of space-time near massive stars. Using general relativity, they found that space-time becomes warped into a tunnel, creating a hole in the universe. Wormholes, also called Einstein-Rosen bridges, are two black holes that connect two different regions of the universe. A black hole is a space-time region where the gravitational field is so strong that no information-carrying objects can escape it. One is formed when the size of a gravitating object of mass m becomes smaller than its gravitational radius. Einstein thought black holes could not possibly exist because of the incredibly unusual set of properties, but after Einstein examined the equations, he realized that the tunnel would lead to another point in space-time. Wormholes are black holes, meaning that they're packed with just as much gravity. But how would you expect to get to the other end of the tunnel without being crushed? Scientists today are talking about anti-gravity, a force that counters gravity. Sure, get yourself a spaceship with an anti-gravity field around it, but we have no idea how anti-gravity works. So why can't light escape black holes? Well, to overly simplify things, think of space-time as a fabric, and black holes rip that space-time thanks to gravity. So as light passes through that fabric and it would come across this rip, it would have no choice but to encounter it. Also, think of escape velocity. A rocket ship would have to be real fast to be able to overcome Earth's gravity, but if you were too slow, you would just end up plummeting to the ground. The thing is, you would have to travel at speeds greater than 300,000 kilometers per second. Take note that the fastest launch velocity on Earth was 58,000 kilometers per hour by the New Horizons probe. Wormholes then seem to be a lost cause. Not until Roy Kerr found that rotating black holes wouldn't collapse to a single point in space-time. Instead, they would collapse to a ring thanks to their centrifugal force. After the tunnel, you would find yourself at the other end of the wormhole, what scientists call the white hole, where instead of matter falling into it, white holes spit that matter out. Disclaimer: most of the concepts I've mentioned today are theoretical. We have yet to find out whether there really are traversable rips in the universe for space travel. And isn't it amazing that human curiosity has led us to wonder about these possibilities? And it does not stop there. Every minute, we progress into understanding our home in the universe.